Welcome to homework.
Okay, so in this problem, we have a support and we have a force F acting on it, right? And we're told that the xy component, or the force in the xy plane of this force F, is 7 kilonewtons. So you can imagine that as this little blue shadow that I drew underneath F. And we're told that the shadow force, right, or the xy component of the force forms a 40-degree angle with the x-axis and a 30-degree angle with the force F itself. So that's the red and green angles that I've drawn in this little diagram here. And so we have to use those to find the magnitude and the coordinate direction angles of the force F. So to do that, we can actually first imagine turning this 3D plane or 3D environment into a 2D plane. Right, so we're actually going to draw a second little diagram of the x and y plane. Right, so now we're 2D again. And our triangle is going to be somewhere in, or our force line is going to be somewhere here. Right? And so we have an angle here. And we actually can determine two values from this. We can determine this value here and this value here. So we can find fx and fy. So to find fx, we just know that it's equal to the magnitude, and in this case our magnitude is 7 kilonewtons, right? Because it's the shadow, and it actually gives us the magnitude of the little shadow line. So 7 kilonewtons times for the y value, it's actually going to be cosine of 40 degrees, or sorry, sine of, for the x value, it's going to be cosine of 40 degrees. Sorry, and if you plug this into a calculator, you should get about 536 kilonewtons for fx. For fy, we're going to do 7 times sine of 40 degrees. And this value, I'm going to plug this into a calculator as well, you should get 4.5 kilonewtons. And if you look at our little diagram, the triangle is going in the negative y direction, right? So we have to throw our negative in there as well. So we have fx and fy, and now we have to shift our attention back to the 3D plane. And we can actually imagine this little triangle that the force forms with its shadow, right? We can use that triangle now to find the fz component. This component right here. I'll just draw a little orange line on it. That component right there. And so now we imagine we're back in the 2D plane and we're just dealing with a triangle. And so now the fz component is, here we actually have, some force times sine of 30 degrees. Oops. Right? And we still don't know what f is. We're still not entirely sure what f is. But we can figure out f by kind of working backwards with what we're given, though. So we'll move back to our little triangle that we've imagined. And remember, we're given this angle, this green angle, which is 30 degrees. And because we know the magnitude of the little shadow underneath, we're really just dealing with a triangle, so we can find the hypotenuse of that, or f, right? So we do f times the cosine of 30 is equal to, and this would be the horizontal component if we're looking at a 2D plane, but in this case it's just the 7 kilonewtons. So it's just 7 kilonewtons. So we divide both sides by cosine of 30, and we get an f magnitude of 8.08 kilonewtons. Now that we have this, we can move back to our fz, and we can determine that fz is equal to 4.04 kilonewtons. And that's just determined by plugging in f into the f that we left for a little bit later. So now we have these three values, right? And using those, we need to determine the angles that, or all the coordinate direction angles, alpha, beta, and gamma. To do that, we have a few formulas we can use, very simple formulas. So for alpha, so alpha equals arc cosine of fx over x. And this is true for all of the components. So it'll be fy over f and fz over f for beta and gamma, respectively. So if we plug in each of these values that we just calculated and the f value that we just calculated, alpha will actually come out to be, I'll write a meter alpha. Alpha will actually come out to be 48.49 degrees. And remember, that's the angle that our force forms with the x-axis. Beta will come out to be 123.85 degrees. And lastly, our gamma will come out to be 60 degrees. Okay, so those are actually our final answers. Those are the coordinate direction angles and the magnitude of our force.